All right, hi folks, this is Larry Mussolino. I'm recording a video for Module 15 in Math 181. So I'm here in the lecture notes. And this unit, this module has to do with working with the normal distribution. So the normal distribution is this bell-shaped curve that you see here. Whoops, let me share my screen. I forgot to share my screen. All right, so here is the Module 15 lecture notes. We're going to be working with this kind of a normal curve. Sometimes it's called the bell-shaped curve that you see here. And we want to be able to find areas underneath this curve. Because it turns out when you find areas underneath the normal curve, it corresponds to a probability. So let me give you a quick example here. Let's say we are interested in IQ scores. Well, here is a bell-shaped curve corresponding to IQ scores. The mean or average is here in the center corresponding to this peak. So in this example, the mean or average IQ score is 100. There's also a number called the standard deviation that gives you a measure of how spread this curve is. In this example, they're telling us the standard deviation is 10. All right, so I'd like to be able to answer questions. Here are some questions. What percentage of people have IQ scores between 90 and 120? So I come here in this bell-shaped curve and I mark 90 on this horizontal axis and I mark 120. And I want to find this red area under the curve in between these IQ scores 90, 120. It turns out this area is 0.82. We would say then 82% of people have IQ scores between 90 and 120. And you might say, well, how do you know the area is 0.82? Well, I'll show you a couple of different ways you can figure that out. One way you could do that is use Excel. Another way you could do it is to use a TI-84 calculator. Another way to do it is to use a utility that our textbook has provided. And if you go to a website called wanermath.com, this is our textbook author, you'll see that there's utilities to help you find areas under the normal curve. I'm going to use Excel here because I think that's going to be the easiest for us to use. Now, one thing to keep in mind is the total area under this curve is 100% or 1. So always the total area under a curve, here it says the total area under a curve would be 100%. It would represent, in this example, all adults in the United States. What we just found out is 82% of them we expect to have IQ scores between 90 and 120. What if I want to know what percentage have IQ scores above 120? Well, these are people with very high IQ scores. And if I was to look at this small red area, here's 120. Here's the area to the right of 120 below the curve. So I want to find that red shaded area. Turns out that area is 0.023. which we could say is 2.3%. So only about 2% of people have IQ scores above 120. Okay? You might notice that there's really a couple of possibilities of questions that you might be interested in. You might want to find the area to the right of a certain IQ score. That's the example we just did. You might want to find the area between two IQ scores. That's the example we did a few minutes ago. I could also want to, I could also ask, what is the percentage, what percentage of people have IQ scores below 80? Well, if I ask that question, I would be finding this area here to the left of 80. So these are the three scenarios of types of questions you might be asked. What's the area to the left? That would be an area below an IQ score of 80. What's the area to the right? That would be an area of an IQ score above 120. Or I could find the area between two IQ scores. Okay, so let's see how Excel would do this for us. Now, If you scroll down to the bottom here, there's some information about a menu that you could use, or you can actually type in a command directly in Excel. Here it is. This is the command to type into Excel to find areas under the normal curve. All right, so I'm going to go do an example. Let me bring up Excel, and let me just show you how to do this. And if you wanted to use a TI-84, here are the instructions. If you wanted to use that utility that our textbook provides, you can follow the instructions in our textbook. This is in section 8.5 in our textbook. And there's instructions on how to get to that utility. But let's use Excel. I'm going to bring up Excel. And here is a Excel spreadsheet that we can use to find areas under a normal curve. So let's do a couple of quick examples here. By the way, I'll email this file out to you so that you can use this. So let me come over here to this example right here. It says, imagine IQ scores follow a normal distribution with a mean 100 and a standard deviation 10. Always a good idea to draw a normal curve. So I'm going to draw a curve like this. And I know the mean is 100. So in the center here, I'm going to draw 100. Find the probability that a person's IQ score is less than 115. All right, well, if this is 100, I know that 115 must be over to the right a little bit. And they want the probability that a person's IQ score is less than 115. Well, less than 115 means going this way. So I want to find this red area under the curve. Okay, well, I'm going to use a command. Let me show you what this command looks like. I'm going to click right here in this box, and you can see the command up here. It says equals norm.dist, then the x value, that's the IQ score, then the mean, then the standard deviation, and then there's a flag here that we're going to leave set to true. True means find the cumulative area under the curve. So in our example, the IQ score is 115. The mean was given as 100. The standard deviation was given as 10. We're going to leave this flag at true. And Excel is giving us the answer 0.933. If you haven't used Excel before, the way you enter an Excel command is you always put an equal sign first. So the way I would work this out, let me show you that quickly. The way I would actually work this, I'm going to click my mouse right here. I'm going to click in any empty cell right here, and I'm going to type in equals norm dist left parenthesis. Now I want the x value. In our example, it was an IQ score 115. Now I want the mean that was given as 100, standard deviation 10, and type in the word true. Hit enter on my keyboard, and Excel gives me the answer 0.933. So about 93% of people have IQ scores less than 115. This question is asking us for a probability. Well, it turns out probability is the same area under the curve. So the answer to that question would be 0.933. All right, let's go to the next example. The next example says, again, IQ scores follow a normal distribution with mean of 100, standard deviation 10. Find the probability that a person's IQ score is more than 104. All right, again, I'm going to draw a diagram because that's always a good idea so that I can kind of visualize the area they're asking me for. Here's the mean of 100. They're saying more than 104. Well, 104 is here, and more than 104 means IQ scores higher. That means the area going to the right. So I want to find this red area going to the right. All right, now here's the tricky part about using this Excel command. This Excel command always gives areas to the left. So let me come over here and notice the way it says Excel uses this command to find area under the normal curve to the left of a specified value. We want to know the area to the right of 104. Well, if we execute a command in Excel, Excel always gives you the area to the left. So Excel is going to give me this blue area if I use that norm dist command. But I can make use of the fact that the total area under the curve is 1 to find the red area. So it turns out I can easily find the red area as 1 minus the blue area. All right, so let's see how this is done in Excel. Let me come over here. I'll click right here on this box. So notice the way this says 1 minus. Up here, look right up here. It says 1 minus norm dist 104. That's the IQ score. The mean is 100. The standard deviation is 10. Again, that norm dist command would always give you the area to the left. In this example, we wanted the area to the right. So that's why we're using the 1 minus setup, because that would give me the area to the right of 104. All right, let me do one more example down here. It says find the area between 2 IQ scores. Here it is. IQ scores follow a normal distribution. Find the probability that a person's IQ score is between 97 and 118. Well, the way I can do this is I can actually subtract 2 areas. So notice up here, it says find the area to the left of 118. That was the higher IQ score. And subtract the area for the IQ score of 97. That was the lower IQ score. Because really what I want is I want the area in between 97 and 118. So I want this blue area. Well, Excel doesn't give you a direct way to get that area. So here's what you do. It's a little trick. First, I'm going to find the area to the left of 118. Okay, so I'm going to find this red area. But then I'm going to subtract this green area to the left of 97. If you notice, if you take the red area and subtract this green area out, what's left over is the blue area. So that's why we're doing the subtraction, where you take the area corresponding to the larger IQ score and subtract the area corresponding to the smaller IQ score. Because when you do that subtraction, you end up with the area in between those 2 IQ scores. Okay. All right, again, I'll email out this Excel file so you can use this as a template, or you can use this to help with some worked out examples. Now, you're going to see some examples that mention a standard normal distribution. Well, a standard normal distribution is really done the same way. Questions for the standard normal distribution are done the same way. The only thing you have to know about the standard normal distribution is it implies that the mean is 0 and the standard deviation equals 1. When you're using a standard normal, we call those z-scores. So we use z-scores corresponding to the standard normal distribution. So if you notice, let me come over here and just show you some of these Excel commands. I'm going to click here. Notice it's the same norm dist command. The only thing that's different is the mean is 0 and the standard deviation is 1. Remember, this is the syntax of how to use this command. All right, folks, let me mention one last item. There's another command you might want to use. It's called norm.inv. This stands for the inverse of the normal distribution. This is kind of like using the normal distribution backwards. Here's an example. It says find an IQ score that cuts off the top 20% of adults. When they tell me the top 20%, they're really giving me the area under the curve. They're telling me that this area is 20% or 0.20. And they're asking me to find this IQ score. All right, well, I'm going to use a command called norm.inv. And for norm.inv, here's the way it works. You enter the area to the left, then you enter the mean, and then you enter the standard deviation. And when you do that, Excel gives you this IQ score back. We call that an X value. An X value is whatever it is you're measuring. It could be IQ scores, it could be blood pressure, it could be test scores, etc. So in our example, what I have to do, though, is figure out what is this area to the left. Well, I know if the area to the right is 0.20, remember the total area under the curve is 1. Well, that must mean this area to the left is 0.80. So when I go to type this into Excel, it's going to be 0.80 here. The mean IQ score is 100. The standard deviation is 10. And Excel would give you this answer here of 108. So a person that has an IQ score of 108 is in the top 20%. Let me click on that box so you can see the Excel command. I'm going to click right here. And if you come over, notice it's norm.inv 0.8. That's the area to the left. 100, 10. Okay, so you could use the TI-84 calculator. You could use Excel. There's a lot of online calculators for finding these areas under the normal curve. You could use the utility from our textbook. You know, it's really up to you. Use whatever utility or technology you find to be the easiest to use. Of course, you'll get the same answer no matter what technology. All right, let me know if you have any questions or if you get stuck on any WebAssign examples, and good luck in the Module 15 homework assignment.